I've gotten us some pictures here of some cubes. So cubes that you would have maybe seen in real life, all right? Over here, let's go grab my magic pen. Right? Over here, we've got the kind of cube that you would put in the freezer. Okay, you would put it in as water, right? Stick it in the freezer and it becomes ice. All right, it's normally in the shape of like a square, but because it's a 3D shape, we say that it is a cube. Right, who can tell us in the chat, what is that kind of cube called? What kind of special cube is that? It's water, you stick it in the freezer and it becomes, what is it? What is it? Who's talking to us in the chat? An ice cube. Well done. Nice, guys. Okay. All right. I'm not sure. Mr. Hugo and I were having a discussion about whether you might be a little bit too young to have seen these before. All right. But maybe you've seen them on TV or heard about them in books, maybe. Okay. They are made out of sugar. All right. You can put them into your tea. All right. Some people, you sometimes use them for baking as well, but they are also known as sugar cubes. And when I teach a maths class and we're doing this for the first time, I normally pass them around class and everybody gets to have a sugar cube, but you can actually still buy these in the shop. All right, so these are what we call sugar cubes. Okay, if we move a little bit up, all right, this is what we normally do when we draw a cube. So that's what it normally looks like. Okay, it's a three-dimensional shape. All right, it also can sometimes look like this one over here, where we draw it with dotted lines as well. Okay, but for me, the most popular kind of cube that we use in real life, and we use a lot in maths as well, is this cube over here. And I'm going to hit it and see if it is working for us. So let's have a look if it lets us. There we go. All right, so that's right, guys. It is a dice. So a dice has how many sides on it? How many sides does a dice have? Who can tell us? How many numbers are there on a dice? 6, good. So a dice is the most popular cube, I would say. Okay, it's the one we use in maths a lot. We use it in board games as well. Okay, it's got 6 different sides. Each side is made up of a square. So there is our dice, which is a cube as well. All right, so those are some examples of cubes in the real world. Okay, let's go have a look at our lesson for today. All right. So the surface area of cubes and rectangular prisms. That's what we're focusing on this week. We're looking at cubes and rectangular prisms, okay? So we might start looking at rectangular prisms a little bit today, and then we're going to really focus them on on Wednesday as well. So the first question says to us, draw a diagram of the net of each of the following shapes. Write the measurements of the shapes on your diagrams. Okay, so we are drawing nets. Now, guys, what does it mean when you're drawing a net? What does a net mean? Well, a net means that you're taking the shape and you're cutting it up. Okay, you're taking it from being a 3D shape, all right, and you're cutting it up to make it a flat 2D shape on your page. Okay, so if we're having a look at the first shape that we've got here, okay, that first shape that we've got here is a cube, all right? A cube, like we saw before with the dice, is made up of 6 faces, and each face is a square, okay? Each face is a square, all right? So let's go grab a piece of paper, right? We need a ruler, everybody. So I'm hoping that tonight you brought a ruler with you guys. Okay, so we've got a ruler and we've got our pencil, all right, and we're ready to go. Okay, so we've got our ruler and our pencil. I'm going to go grab my ruler. Oh, that's not a ruler. All right, my ruler. make him a bit bigger so you can see him. And my pencil. Now, that cube had a square that was 5 centimeters by 5 centimeters. So that's the first thing I'm going to start by doing. I'm going to draw one square that's 5 centimeters by 5 centimeters. That's my first thing. Okay, so I'm going to start kind of like in the middle of my page as best I can. Right, I'm grabbing my pencil, right, and I'm going to go 5 centimeters. Okay, and I'll take my ruler. And move it up this way. Right. I'm going to draw 5 centimeters that away. Making a little bit of a mess here, huh? Thanks. Move the lines a bit better. There we go. Right. I'm going to move my ruler. I'm going to draw 5 centimeters this way. Okay. And I'm going to draw 5 centimeters this way. All right, so there's my first square. Okay, there's my first face, face number 1. If I want to, I can go tell myself that's the first one. Okay, so that's the first one. All right, so then you've got to think to yourself, you've got to picture this square. Okay, if you had to take the square, you had to cut it up and look at all the different sides of this square. What would we be seeing here, everybody? Okay, we'd definitely have to see, all right, I don't have a box on me at the moment, oh dear. Okay, so we'd definitely have to see one square that's sitting at the top, the lid of the cube, okay, all right. Then what would we have, all right? We would have another square straight underneath it. All right. So there's my next one, straight underneath it. Okay, so you guys are going to take your rulers again. You're going to go draw another square that's 5 centimeters by 5 centimeters by 5 centimeters. All right. And that would then be the second one. All right, we got 2. We need 4 more, hey? Okay. Umar, you are right. Mine is slightly off. That is correct, but you can do yours nice and straight. Okay. All right. So keep on going. All right. I'm going to clone mine again. Oh dear. See if I can get it a little bit straighter so that it's in line. All right, this will be my number 3. And then I'll have my number 4. Okay, so there's all 4 of mine when I cut them down. All right, somebody's asking me, must they touch or must they be separated? They must definitely touch. Why must they touch? Because when I cut that square up, when I cut them open, they're still going to be touching slightly. Okay, so we're just making the square from going 3D to being 2D. All right, so I've got 4. I need to have 2 left. Now, grade 7s, it's up to you guys while you're drawing those 4. It's up to you guys where you put those last 2. Okay, normally, all right, teachers go and they put them, okay, they put them on this second one. All right, so they go here and they say, okay, you're going to draw your last 2 on here. You're going to go here. Just going to draw it here quickly. Oh dear, the page is a little bit too small. Oh, perfect size of this page. Perfect, perfect, perfect. Lucky. All right. Let's draw this line up. Okay, so you could put them there, or you could put them on the top one, or you could put them on the third one. It really is up to you, as long as you've got those 2 sides. Kale's asking me, ma'am, can we just make 2 long lines, the sides of all 4 squares, and then do the horizontal lines after? Yes, Kale, that is fine, as long as it looks like a net. That's perfect. That's absolutely perfect, yes. Okay. All right. So this one will be number 5, and this one will be number 6. Okay. Do we have to put folding lines to tell where the shape folds? Yes. Ma, you do have to put those lines in to show where it folds. Absolutely. Yes, you do. All right. So you do have to show that there are 6 different squares. So you can do that with either folding lines, you can do it with dotted lines, or you can do it with solid lines. Either way, it's okay. All right, I'm going to give you a few seconds to catch up to me here, to draw your shape. Okay. All right. Of course, if you've got square paper, guys, square paper grids, it's a lot easier. It is a lot easier if you've got square paper grids. But you don't always, not every teacher gives you square paper grids. And also, when you get to next year and you get to high school, you don't get square paper grids all the time. Okay. Okay, I'm going to give you guys 1 more minute. I know some people are saying, ma'am, I'm done. 1 more minute to try that out. All right. While you're busy saying you're done, there was another instruction. It told us that we have to put the measurements on this net. So let's go put our measurements in quickly. So we need to tell them that this is 5 centimeters, 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 5 centimeters. So I've just thrown in a whole lot of 5 centimeters all the way. Okay. Ma'am, don't forget the flaps. Ma, you are right. Sometimes you would have flaps, but in this case, they didn't ask us to draw the flaps, so you don't have to. Okay, so I know that some teachers do, they draw the flaps in as well, and that's normally when you are drawing a cube that you're going to stick together. So yes, but in this case, we're not going to draw flaps because we're not actually sticking it together. All right. Ma'am, your 5 centimeters looks like 5 a.m. Sorry. My handwriting sometimes is not great. Hopefully you can see it's 5 centimeters. Ma'am, do we have to cut the cubes? No, we're not cutting the cubes out. All right. while I'm giving you that 1 minute to go and write in your 5 centimeters, ma'am, are you going to teach us next year, or Watobe only ends in grade 7, or we're going to have another teacher? It all depends on the numbers, guys, and who's teaching who. They make those decisions at the end of the year, so you will find out at the end of the year. Okay, so yes, Watobe carries on. There is grade 8 Watobe as well, but they will let you guys know who your teacher will be after that. All right, so hopefully you've got that one done. Let's go have a look at our next question. All right, so we are going to go and have a look now, okay? Oh, yeah. We're going to leave the rectangular prism for now, guys. Why are we leaving the rectangular prism for now? Because we're going to do rectangular prisms on Wednesday night. So for now, we're going to leave that rectangular prism and we're going to come back to it on Wednesday night. So we're going to look at all the cubes for tonight. So the next question says to us, calculate the surface area of each of the following opened out boxes. Each square on the grid is 1 centimeter. All right, so we're going to ignore 2.1 and we're going to ignore 2.2, and we are having a look at 2.3 only. So I want you guys to have a look at 2.3 only. This is really similar to what we did when we were first doing area the other day. Okay, when we were first doing area the other day, everybody. So what they're saying to us is that each of these squares, okay, each of these little squares over here, all right, is equal to 1 centimeter. So in other words, each square is 1 centimeter squared. All right, 1 centimeter squared. Okay, so what they've done for you is they went and they took this cube in 2.3 and they opened the cube up for you. Okay, they opened the cube up, and what they want you to do is they want you to calculate if each square is 1 centimeter squared, each one of these little squares, then they want you to tell them what would the surface area, so the total area of all of those squares, be for 2.3's shape. So I want you to go have a look, go work it out for me. 2.3. I'm going to give you 3 minutes to go work it out. Some of you might not even need 3 minutes. Go try for me. 3 minutes. 3 minutes. Okay. All right, 3 minutes. So each square is 1 centimeter squared. Okay, you've got 3 minutes. All right. Okay, let's have a look at some of your questions in the meantime. Ma'am, are we going to have the same teacher next year in grade 8? Again, it all depends on the numbers and what Watobe's decisions are. Ma'am, I know you sometimes teach Maths Lit. I do sometimes teach Maths Lit. That's right. Okay, I also fill in for other lessons as well. All different teachers, we all fill in for each other sometimes. Enzo sent me the answer. Enzo, go try again. There's a little problem with your answer. All right, Kimo, ma'am, what should we do? Kimo, you are working out what the surface area is for that shape. All right, Enzo, your answer is much better. Well done. Okay, Itandile, we're going to do it together in 1 more minute. I'm giving everybody 1 more minute. All right. Okay, good. I'm seeing some good answers. Well done, Kaylee. Well done, Similize. Well done, guys. All right. Lungawa, I'm guessing you're wanting to give me the answer. That's why you like clapping at me and singing at me there. Hands raised. Hey? Okay. All right. 1 more minute. Okay, everybody. Lungawa, where did you go? You're going to help me with the answer. Hi, Lungawa.
Hi, ma'am.
How are you?
I'm fine, and you, ma'am?
I'm good. Right, Lungawa, talk to me. How did you work it out?
Ma'am, I didn't want to do the answer. I wanted to ask you something else.
Okay, ask me. What's up?
I was gonna say that can ma'am quickly go up, please?
Can I go up, please? Sure, of course I can. No problem. Let's go see. Oh dear, no, that's there.
Yes, ma'am.
What's up?
I just wanted ma'am to go up.
Oh, okay. Is that all?
Yes, ma'am.
Okay. Can I move it back down now?
Yes, ma'am.
Okay, cool. All right. Are you going to help me with 2.3 or are you not sure?
Can ma'am explain it to me again?
Of course I can. Okay, I'm going to explain it to everybody. Thanks, Lungala.
Okay.
All right, guys. So for 2.3, if I'm looking at this, all right, I can see that I've got a cube. And in this cube, I've got 1, 2, 3, 4, 5, 6 of the exact same square. So the square is exactly the same for all of those, okay? So I've got the exact same square 6 times here, okay? So if that's true, that means that I can work out what the area is for one of those squares. So in one of these squares, if I go work out the area, I can see that I've got 1, 2, 3, 4 blocks. And if each block is 1 centimeter squared, then for one block, for one whole square, it's going to be 4 centimeters squared, okay? So I'm going to go say that the surface area is going to be equal to 6, because there's 6 of those squares, times by 4 centimeters squared, because that's the area of one of the squares. And 6 times by 4 is going to give me 24 centimeters squared. So what did we do? We worked out the area of one of the squares, and then we saw we had 6 squares, so we times it by 6. Okay. All right. The next one is a rectangle, and like I said to you, we're going to have a look at rectangles a little bit later on. We might even start rectangles in this lesson. Let's go have a look at question 5. Question 5 says, calculate the surface area of the following boxes. Remember to first draw a diagram of the net of each box. So these boxes that they've got here are all rectangles. I'm going to go draw a cube for you that isn't a rectangle. I'm going to go draw one that's a square. So I'm going to go do a 5.4 for you. Okay, see if I can do a 5.4 for you here. So let's insert one here for you. We're going to say 5.4. So you're going to calculate the surface area of the box. Okay, remember to first draw the net. Okay, so to remember to first draw the net. All right, so calculate the surface area of the box. Remember to first draw the net. Okay, so let's go get a nice cube for you guys, and we're going to put that cube in there. And let's take another cube because we're going to do 2. All right. So for the first box that I've got, I'm going to call it box A. Okay, box A. Box A is going to have sides of 10 millimeters, 10 millimeters, 10 millimeters, okay? And then we're going to have box B, And box B is going to have sides of 6 centimeters, 6 centimeters, 6 centimeters. So go have a look at A and B for me. Draw the net if you need to look at the net first. All right, so first you need to draw a net if the net helps you, and then you're going to calculate what the surface area is. Remember what we did in the last one? Okay, we saw that there was a net. We saw that there were 6 sides. Okay, go and have a look at that for me. All right, so you're going to start with A. Okay, I'm going to give you 3 minutes for A, and then we're going to move on to B. So go have a look at A for me. We're going to start with A, and then we're going to move on to B. All right. Okay, you have 2 minutes left for A. You have 2 minutes left for A. Take it slow. 2 minutes is a long time, guys. The net doesn't have to be perfect, just has to be a quick drawing. Okay, 1 minute left for A. All right. Seeing lots of good answers in the chat, Mr. Hugo. I don't know if you've seen them as well there. They're doing really well.
There's a bunch coming through on my side as well, and they look interesting. I won't say they're all the same, so some have to go take another look.
Absolutely. Some people are rushing, I think, okay?
I think so too. 2 minutes are a long time, guys. 2 minutes is a long time, so make sure, guys, of your answers.
Okay. All right, guys. Let's go and do number A together. Okay, let's go have a look at number A. All right, so the first thing that we want to do for number A, okay, first thing we want to do with number A is we want to see first, all right, what the net would look like. So what would the net look like? Now, I'm not going to draw the net all nice and neat, all right, because I'm just using it to help me. So when I draw my nets, I'm going to go do it like this. 1, 2, 3, 4. There's my 2 arms on the side. They kind of look like squares, all right. What do I notice about the net? I have 1, 2, 3, 4, 5, 6 cubes. So for A, I can see that there are 6, not cubes, sorry. I have 6 squares. So the surface area is going to be equal to 6 times pi, and all those squares are exactly the same, okay? This area for a square is the same thing as saying side times by side or side squared. So we can either say side times side, or we can say side squared. Or I remember when we were doing area the other night, somebody said to me, oh ma'am, what about length times breadth? That's even fine as well. You can do length times breadth, same thing, right? So now I'm going to have 6 times pi. What's the side equal to? It's equal to 10 times pi, 10. So 6 times 10 times 10. Well, in the bracket, I've got 10 times 10. 10 times 10 gives me 100. 100 times 6 will give me 600. And I need to make sure I finish off my answer. So I write millimeters squared. Okay, millimeters squared. All right, I'm gonna let you do B now by yourself. So go try B for me. Go try B. Now that we've done A and you've seen how to do A, go try B for me. Okay, I'm giving you 2 minutes to do B. Go try B. All right, remember what Mr. Hugo said. 2 minutes is actually a longer time than what you think. All right. Sishle is asking me, ma'am, where does the 5 come from? Sishle, that's not a 5. It's 6 times S times S. It's an S, not a 5. It's an S. It's my handwriting. 6 times side times side. Okay, 1 more minute. Oh, I'm seeing some good answers. 1 more minute. Right. Okay, who's helping me out with B, guys? Umar, your hand was up first. Right, Mr. Umar. Let's go, Umar. How do we do B? Umar, you unmuted. Oh no, Umar, I hope there isn't a problem with your sound again. Umar, can you hear me? All right, maybe I think there might be something wrong with Umar's sound again tonight. You can hear me, we just can't hear you. Sorry, Umar. All right, we're gonna go to Jaden. Hi, Jaden. Jaden, is your mic also not working maybe? Oh no. All right, we're gonna move to Amishle. Hi, Amishle.
Hello, ma'am.
How are you?
I'm good, and you, ma'am?
I'm good. I was starting to get worried. I was talking to myself. Right, Amishle, talk to me. How did you do this?
So, ma'am, I said surface area equals 6 times, and then in brackets I had 6 times 6.
Well done.
And
awesome.
Then I said 6 times 36.
Good, nice. 6 times 36. Cool, because you did it in steps. Well done.
And then I got 216, ma'am.
Good. 216 what? Bananas, apples.
Oh, millimeters squared, ma'am.
Good. Centimeters squared. Well done. Thank you so much, Amishle.
You're welcome, ma'am.
All right. Awesome. Amishle is perfectly right. She said 6 times by 6 times 6, and that gave her 216 centimeters squared. Well done, Amishle. Okay, guys, let's go have a look at some more examples. So if we go back to our worksheet, let's go back to where we were before. All right, so let's move down here. It says, calculate the surface area of the following boxes. Remember to first draw a diagram of the net of the 3D shape. Now, for some of you, you guys are doing quite well with not having to draw the net with a cube. And if you can do it without drawing the net of the cube, then that's fine. We're going to see when we do the rectangular prism on Wednesday, why it's important that we do draw the net. But go and have a look for me. 6.1, 6.2, and 6.3. Go and do the surface areas for those ones for me, guys. Go have a look. Oh, and our screen gave up on us again. My goodness. So let's go reconnect quickly. All right, so we're going to go and have a look at the nets for those ones. Okay, a reminder, you don't have to always draw the net. If you can do it without drawing the net, then that is okay for the cube. But when we're having a look at on Wednesday night, when we look at doing our rectangular prisms, then it's going to be really important that we do draw the net. So just a reminder for tonight, I'm happy for you to do it without drawing the net, but we will have to do it with the net on Wednesday. Okay, so there's 6.1, 6.2, and 6.3 for me. Okay, we have a few minutes left, so you guys can choose which one you want to do. I would take a screenshot of all three, so you've got all three, because I will go through all three of them with you very quickly, but I want to make sure that you at least try and do one by yourself as well. So go and have a look at those ones for me. Okay, I'm going to give you 2 minutes. You pick which one you want to do. You go try 6.1, 6.2, or 6.3. I'm going to do all three for you when we go through them. Okay, but I want you to have tried at least one. If you can't do all three in this time, all right, go try. Nice. I know it's a really short time. Our lesson goes by so fast. That's the problem. I wish it was longer. Okay, so I'm going to start by asking Omar because he has fixed his microphone. Okay, so I'm going to ask Omar to help me out with 6.1. Hi, Omar.
Hello, ma'am.
How are you?
I'm okay, and you?
Good, thanks. Right, Umar, talk to me. How did you do 6.1?
So ma'am, I put SA equals to 6
Cool.
bracket
Yeah.
20 times 20.
Good. Well done. 20 times 20. All right. And what did you get?
2,400 centimeters squared.
2,400 centimeters squared. Well done, Umar. Thank you so much. Thanks, Umar.
Bye.
Bye. All right. So Umar got that one down. Okay. What I am hoping to do, if I can get it right here, is I want to lower all your hands. Is there anybody who wants to go through? Let's do that quickly. Anyone who did 6.2 and who wants to help me with 6.2? Who's done 6.2? All right, Jabulile. Hi, Jabulile.
Hi, ma'am.
How are you?
I'm good, thanks, and you, ma'am?
I'm good. Right, Jabulile, talk me through 6.2. What did you do?
Ma'am, I said 6 and then in brackets 32 times 32.
Good. 32 times 32. Awesome. And what did you get?
It gives me 1,024.
1,024 monkeys. And
millimeters square.
Thank you. Millimeters squared. Don't forget, hey? Don't forget the millimeters squared at the end. Otherwise, you'll lose some marks. Yes, talk to me.
Ma'am, do we not have to times that number by 6 again? Because it was put in brackets. We said 6 times in bracket 32 times 32. So do we not times our answer by 6?
What is 32 times 30? Is 32 times 32 1,024? I was just trusting you to give me the whole answer. Let's see. Let's see. 32
sorry,
times 32. That's okay. All right.
The total answer is 1,642. 44 millimeters squared.
Say it for me again. The total answer is
1,644.
6,144 millimeters squared. Thank you.
1,600.
Are you sure? So let's go. I'm going to do it on my calculator. 6 times 32 times 32 equals. I get 6,144. Double check.
Okay.
Double check. Double check. Go double check for me. Thank you so much.
Ma'am.
All right, guys. And the last one. I want to have a look at the last one. Who wants to help me out with this last one? This last one's tricky. All right, Noah. Hi, Noah. Noah, can't seem. There we go. Noah, do you want to unmute yourself and do 6.3 with me? Oh dear, I don't know why I can't unmute Noah. Oh, and Noah's gone. Okay, let's go. Itandile. Hi, Itandile. How are you?
How you doing? I'm good, and you?
I'm good. Right, Itandile, 6.3. Let's go.
Okay, this is what I say. SA is equal to 6 times 0,4 times 0,4.
Good. 0,4
then-
times 0,4. Yeah.
And then the total answer was 0,96.
0,96. Now, I trust you. I promise I do. I'm just going to go do it on my calculator just in case, eh? Times 6 gives me 0,96. 0,96 butterflies. Yeah. 0,96 what?
Millimeter square.
Meters squared, hey?
Yes, ma'am.
Careful. Thank you so much for your help, though. I'm glad that you got it because you were saying earlier you were confused. So well done.
Thank you, ma'am.
Thanks, Itadile. All right, guys. So that is the surface area of the cube. You guys did really, really well. Well done, everybody. Okay, you did really, really well tonight. I'm really, really proud of you. Okay, we managed to cover all the examples and we threw in some extra examples on Wednesday night. And I saw some of you said to me, oh, ma'am, or somebody said, man, I already went and screenshot the ones for Wednesday to go and do them for practice. Well done. I'm really proud of you for doing that. On Wednesday, when I see you guys on Wednesday night, we're going to have a look at the rectangular prism and why it's so important that we draw that net. Okay, so make sure you're here on Wednesday. Wednesday night's going to be really, really important. We're going to look at rectangles and looking at the surface area of a rectangular prism. Mr. Hugo is going to put up the poll for you. All right, I'm going to stay here and check that there might be anybody who has any more questions. All right, so I'm going to lower everybody's hands now. If you have any more questions, you're more than welcome to stay. If you don't have any questions, thank you so much, guys. We will see you on Wednesday for another really, really great lesson. Thanks, grade 7s. Bye. Make sure you answer the poll first before you go. Bye, guys. All right. So I've got, I hope I say this correctly, Shaylin.
Hello.
Hi there. How are you?
I'm good, and you?
I'm good. Right. What's your question?
Ma'am, I didn't want to ask a question. I just wanted to tell the people that units of measurement is very important.
It really is. You are right. It is very important.
Yes, ma'am.
And if you don't put them in, your teacher takes marks away. Am I right?
Yes, that's true.
Exactly. So it really is important. Thank you so much for reminding everybody. I really appreciate that.
Welcome. Bye.
Okay, bye. All right, let's go. And Mishle. Hi, Mishle.
Hello, ma'am.
Oh, you're back. Hi, Mishle. What's up?
Ma'am, I just wanted to ask, ma'am, for like the total surface area of a square, ma'am, can you also say like 6 is square, ma'am?
6 is squared. Yes, absolutely. That is absolutely correct. Because all it is that sometimes math teachers get a little bit lazy, and so we don't want to put the time sign in. So 6s squared is perfect.
Okay, thank you, ma'am.
Thank you. All right, Langoa.
Hi, ma'am.
Hi, what's up?
Can ma'am please go up to the very first part?
The very again.
Yes, ma'am.
I love my worksheet so much. You want me to go all the way back up again? There we go.
By number 2, ma'am.
Number 1.2, this one here on the rectangular prism.
Yes, ma'am.
What's up?
I just wanted to write something quickly down.
Oh, you want to take it down so that you prepared for Wednesday, hey?
Yes, ma'am.
Okay, no problem. All right, I'm going to answer the next question so long. Thanks, Langoa. All right, Amashle. Hi, Amashle. Mashle, you should be able to unmute yourself.
Hey, ma'am.
Hi, how are you?
I'm fine, ma'am. I just wanted to ask that why we need to push the net.
Sorry, say it. Why do you have to? Why do you have to put the net?
Yes, ma'am.
So for cubes, it's not necessary. I agree with you because it's so easy. It's 6 squares, hey? So it's really easy.
Yeah.
So for the cube, it's not necessary. But you'll see when we do the rectangular prism on Wednesday, it's a little bit more tricky. And so doing a net really helps us on Wednesday.
Okay, ma'am.
Okay, but I'm also going to maybe try to teach you a cheat on Wednesday as well. So that maybe even if you don't want to draw the net, you don't have to. But so I'm going to show you 2 ways of doing it.
Okay, ma'am.
So,
Thank you.
because do you not like to, I don't like to draw the net either. I find it's so complicated. I get really confused sometimes.
Yes, ma'am.
I'm like, how many squares have I got? How many rectangles? I don't blame you. Okay, but we'll have a look on Wednesday, all right?
Thank you, ma'am.
You're welcome, Amashle. See you on Wednesday.
Yes, ma'am.
Bye. All right, let's go. Lejo?
Oh, ma'am.
Hi.
Oh, ma'am. Hi, ma'am. How are you, ma'am?
What? Finding you.
I'm good, ma'am. I'm good, ma'am. Ma'am, I just wanted to ask a question, ma'am. Ma'am, for term 4, ma'am, will algebra be very, very important, ma'am? Because I haven't been studying it that much.
For term 4. So algebra will
Yes,
be in your exam, definitely. It'll be in the exam. So definitely when, are you going to the boot camp? Did you sign up for the exam boot camp?
Yes, ma'am. Yes, ma'am, I did.
Okay, so when you do the exam boot camp, you'll definitely be doing it in the exam boot camp, all right? So
Okay,
make sure that you do some of the algebra, all right? Because definitely it's
Yes, ma'am.
important. Next year, you'll do a lot of algebra, and when you get into high school, and in the exam boot camp, they'll be going over algebra as well, okay?
Okay, ma'am. Thanks, ma'am.
All right, and then do you know where you can get lots of practice on algebra? More
Yes, ma'am, I
practice.
do. Yes, ma'am.
Okay, good. I'm glad. So you've got some sites that you can go practice on. Cool. All right.
Yes, ma'am.
Make sure
Thanks,
that you
ma'am.
are practicing though. Thank you.
Thanks,
Bye.
ma'am.
All right. And last question for tonight. I've got Tando. Hi, Tando.
Hi, ma'am.
How are you?
Good and you, ma'am?
I'm good, thanks. What's up, Tando?
Ma'am, I have a question about question 6.
Question 6. Let's go see. Yes. What's one?
So, ma'am, question 6, 6.1, are you not supposed to say 2,400 centimeters times 6?
Let's go work it out slowly. You ready?
Yes, ma'am.
Okay, let's work it out slowly. So we should say surface area equals 6 times 6 S times S. So that's the first thing we should say. Then we're going to say 6 times 20 times 20 here. So 6 times 20 times by 20 gives me 400.
Oh.
And 6 times 400 gives you 2,400 centimeters squared. I like doing things with steps. Yeah. Because when you do it in steps, then it just makes it a lot clearer. Am I right?
Yes, ma'am.
Yeah, when you skip the steps, then you miss out on stuff. So I don't blame you. Thanks.